Welcome to my channel.
Hello. So we were solving exercise 1.2 Federal Board New Mathematics book, and we were on question number 4. The question number 4 says use the properties of exponents to simplify each of the following. We already know in the last video we have been through the properties of in the last two videos we have been through the properties of exponents and radicals and conversion from exponents to radical, both of them. So you can watch those videos, and today we're gonna move forward. So the first question says solve this one or simplify this one. And if we're gonna look here in the numerator, what do we have? In the numerator we have two similar numbers, and which are raised to some power, means some exponent. So it means these two numbers are bases, so base are similar. And when you have two numbers where they are being raised to some power and they are similar, means their base are similar, then if bases are similar and they are being multiplied, then we're going to add the powers. So power is 1 by 5 plus 1 by 4. Denominator will remain right now as it is because we are right now working on numerator. So now we're going to add the powers, and exponents are actually right now fractional exponents. So to do this and to add the fractions, our denominator must be similar. So how we can make our denominator similar here? This is 5 and this is 4, and we want to make the denominator similar. And to do this, what we can do is we are supposed to think of a number with which we can multiply 5 to get 4, and we do know there is no such integer. I'm talking about right now integer 1 2 3 like this. So there is no such number which can give us no integer which can give us 4. Simply there is no such integer with which 4 can be multiplied to give you 5. So we cannot actually right now make the denominator similar by multiplying any one of the denominator by any other number. So what we can do, we can think of a number which is divisible by both 5 and 4. So that number is, if we're going to look for the in the table of 5, so in the table of 5 we have 5, but 5 is not divisible by 4. Then we have 10 is divisible by 5, but it's not divisible by 4. Then we have 15, it's not divisible by 4, and then we have 20. So 20 is the number which is divisible by 5 and 4 as well, because 5 4 times is 20 and 4 5 times is 20. It means we can what we can do, we can make the denominator equals to 20. So what we're going to do, in the first fraction we're going to multiply 5 by 4 to make it 20, and in the next fraction we're going to multiply 4 by 5 to make it 20. And if we are multiplying something in the denominator of the fraction, we are supposed to do the similar thing in the numerator as well. So here we multiplied 4, so we're going to multiply 4 in the numerator as well and here as well. And the denominator will remain as it is, 16 raised to the power minus 3 over 10. We're going to multiply the exponent 16 raised to the power 4 over 20 plus 5 over 20. So denominators are similar. So when denominators are similar of a fraction and you want to add them, what you are going to do? We're just going to we will just add them. Add numerator and denominator will remain as it is. So denominator 20 remain as it is, and 4 plus 5 will become 9. Then we go to the denominator is 16 minus 3 over 10. Now right now we have a single fraction. In this single fraction, what we can see that numerator and denominator, whatever we have in the denominator and numerator both have the similar base. Then their exponents are going to be subtracted. So 9 by 20 minus 3 over 10. So we're going to subtract both of them. Now to solve it further or to subtract them, what we are supposed to do is we are supposed to first make this there, because there are right now two signs. So what we'll do first, we'll try to make them a single sign, and then we do know minus, and when you have two minus, that will make a plus. So plus 3 over 20. Now if we want to add these two, what we have to think, that the denominator, we want to make the denominator similar. So if you look for this smaller number 10, we are supposed to think for a number with which 10 will be multiplied to get 20. Okay, that is the technique. Now you are going to look for one of the denominator and look for any other number with which it can be multiplied to get the other denominator. So right now 10 is the smaller one, so we are going to think of a number with which 10 can be multiplied to give you 20. So that number is 2, because 10 2 times is 20. So what we're going to do here, 16 raised to the power 9 over 20, and here we're going to just multiply it by 2, because 2 times 10 is 20. And if we are multiplying the denominator by 2, we're going to multiply the numerator by 2 as well. So 3 will be multiplied by 2, and it will become 16 raised to the power 9 over 20 plus 6 over 20. Now denominators are similar. What we're going to do, we're just going to write the denominator once and the numerator will be added. So 9 plus 20 will remain as it is in the denominator, and 9 plus 16 will become 15. Now whenever you have the fractional exponent, you're going to think whether they are written in the simplest form or not. If the fractional exponent is not in the simplest form, you are supposed to write that in the simplest fraction. Okay, so 15 and 20, they both are divisible by a similar number, that is 5. So 5 3 times, so we're going to cancel them by a similar number. 5 3 times 15 and 5 4 times 20. So it will be 3 over 4. So this is the simplified form of this. If we want, we can simplify it further, or we can put it here. And if you want to simplify it further, what we are going to do, we are going to write 16, because 4 is in the denominator, which shows that we want to trying to find out the fourth root. So we will think of a number which is being multiplied with itself 4 times to give us 16. So that number is 2, because 2 times 2 is 4, 4 times 2 is 8, and 8 times 2 is simply 16. So why we did this? To simplify it further, because we do know that we want to, here it means third power and fourth root of the 16. So fourth root means we are trying to look for a number which can be written as a product of a number being multiplied with itself 4 times. And we do know when something is multiplied with 4 times with itself, it's simply that number raised to the power 4. And we do know 4 is here in the numerator and this 4 is in the denominator. This 2 gets cancelled and we will be left with only 2 raised to the power 3. And 2 raised to the power 3 means we're going to multiply 2 3 times. So 2 times 4, and 4 2 times is 8. So the answer will be simply 8. Now we have question number 2. If you are going to look at this question number 2, here the both numbers are with a similar basis, but exponents are different and they are being subtracted. So actually there is no rule when you have two numbers with similar base are being subtracted, so we cannot do anything inside. But what we can see here, that this thing is inside a group. You have a number which is being multiplied. As you know, there is no sign between the group and this number, so it means that's the multiplication. And when we want to multiply a group by a single number, what we're going to do, we're going to distribute the copy of that number to all of the elements of that group. So in this group we have two terms, 7 raised to the power 5 over 3 and 7 raised to the power 4 over 3. So we are going to distribute this 7 raised to the power minus 1 over 3 to these two terms. So 7 raised to the power minus 1 over 3 times 7 raised to the power 5 over 3 minus 7 raised to the power minus 1 over 3 times 7 raised to the power 4 over 3. For the times we can write dot, or we can write the multiplication as well. So I can put it here instead of multiplication. I can, if I do want, I can write the dot as well, but I like to use the multiplication sometimes, so right, I'm gonna use this. Here we have if you look at this first term, in this first term we have two numbers with a similar base and they are being multiplied. When you have similar bases and they are being multiplied, what we'll do, we'll just gonna add their powers. So exponents 1.3 1 minus 1 by 3 plus 5 over 3 for the first term. And if we're gonna look for the next term, which is this one, which is also having two numbers with a similar base, so and they are being multiplied, so we are going to add the powers. So minus 1 over 3 plus 4 over 3. Now if we want to, for which were being added, but here if we want to add or subtract them, what we need to do, we need to make the denominator similar. Denominator is already similar, so 3 will remain as it is in the denominator, and in the numerator we have whatever we have in the numerator, that will be written as it is, which is minus 1 plus 5. Similar thing will happen here as well. Denominator will remain similar and the numerator will become minus 1 plus 4, because whatever the numbers we have in the numerator, that will be operated as it is. Then 7 minus, we do know when you have two numbers with the opposite signs, they are going to be subtracted. So 5 minus 1 is 4, and sign will be used of the larger value, which is 7 raised to the power 4 over 3, minus here again. Both are when you have two numbers with a similar with opposite signs, they are going to be subtracted. So 4 minus 1 is 3, and sign will be used of the larger value, which is 4, and having the positive sign. And what do we know, what we can here this exponent cannot be simplified, because they are not divisible by a similar number, or they do not have a common factor. But this number 3 and 3, they both have a common factor, which is 3, and so 3 and 3, 3 1 times 3, and 3 1 times 3. So it will be 7 raised to the power 4 over 3 minus now we have question number 3. In the question number 3, if we look, we have in the numerator we have two numbers with a similar base, and in the denominator we have another number with a similar base. So to solve them, what we need to do, numerator we have numbers with a similar base, and this dot is representing that they are being multiplied. So when you have two numbers with a similar base and they are being multiplied, then you're going to add their powers. So 2 by 3 plus 1 over 7. And in the denominator it will remain right now as it is, 2 raised to the power 1 over 2. Then in the numerator, so if we want to add them, our denominator should be similar, and if we're going to look for the multiples of 3, we cannot get 7, because the table of 3 is simply 3, 6, 9, so it means after 6 it's directly 9, and we can't get 7. Similarly in the table of 7, it's 7, 14, 21, so it means we cannot get 20 we cannot get 3 as well in the multiples of 7. So what we're going to do, we're going to think of a number which is divisible by both 3 and 7. So first we're gonna start with this the multiples of this bigger number 7. 7 has the first multiple 7, which is of course divisible by 7, but it's not divisible by 3. Then we have 14. It's of course is the multiple of 7, so it's divisible by 7, but it's not divisible by 3. Then we have 21. So 21 is divisible by 7 because it's in the table of 7, and it's also divisible by 3 because it's also present in the table of 3. 3 7 times is 21. So what we can do, we can make our denominator 21, because 21 is the number which is divisible. You would say the smaller number is the number which we can say the 21 is the number we got that is divisible by both 3 and 7. So to make 3 equals to 21, so 3 times 7 is 21, and if we are multiplying something in the denominator, do the similar thing in the numerator. Then if to make this 7 21, we're gonna multiply 7 by 3. And if we are doing something in the denominator, we're going to do the similar thing in the numerator as well. And for this one, the denominator will remain as it is. So in the denominator, we're going to add the fractions. Fraction denominator is similar, so it will be written as it is, and numerator will be added. Simply 14 plus 3 will be 17, and 2 to the power 1 over 2. And we have two numbers we can see in the numerator and denominator which are having the similar base, and whenever we're going to have the numerator and denominator having similar base, and then the powers are going to be subtracted. So 17 over 21 minus 1 over 2. Now to subtract them, what we have to do, we are supposed to make the denominator similar. Now to make the denominator similar, I know in the table of 2 we cannot get 21, because 2 10 times is 20, because in the table of 2 10 times is 20, and 2 11 times is 22. So after 20 you will directly get 22, not 21. And similarly in the table of 21 it's 21, then 42, so we cannot get 2 in the table. So we are supposed to look for a number which is divisible by both of them. So for this we can look for the table of both of the numbers. So let us try to go with this bigger one, 21. So 21 times is 21, and this is not divisible by 2 because odd number. Then we have 21 times 2, which is 42. Yeah, so this 42 is the number which is divisible by 2 as well. Why it's divisible by 2? Because it's ending at 2. Whenever you have some number which is ending at 0, 2, 4 or 6, 8, then it's simply divisible by 2. So we got this 42 is divisible by 21 because it's present in the table, times table of 21, and it's also divisible by 2 because it's ending at 2. So it's an even number, and every even number is divisible by 2. Now we're going to subtract them. So we'll make the denominator 42, and to do this we're gonna multiply 2 in the denominator of 21. 21 times 2 to make it 42. 17. If we're doing something in the denominator, we will do the similar thing in the denominator. Minus, here we want to make it 42, so we'll multiply 2 by 21. We can check the calculator that with which number we can multiply 2 to get 42, and that number is 21. And if we are doing something in the denominator, do the similar thing in the numerator as well. Here 17 2 times is 32. 32 over 40. 17 times 2 is 34, and 21 times 2 is 42. Here 21 times 1 is 21, and this 21 times 2 is 42. Denominators are now similar, and if denominators are similar, we're going to subtract the numerators. So denominator will be written as it is, and 34 minus 21, we are going to subtract them. 34 minus 21, because both are with the opposite signs. When 34 will be subtracted from 21, we're going to get 34 will be subtracted from 21, we're going to get 13 by 42. Now we have question number 4. If we look in this question number 4, in the numerator we have two numbers with a similar base, which is 3, and they are being multiplied. This dot is representing that they are being multiplied. And whenever you have two similar numbers with a similar base, their powers, and they are being multiplied, their powers are going to be added. So the exponents minus 1 by 2 plus 1 by 2. But the denominator will remain as it is right now. We are not going to do any work on the denominator. After this, if we want to add, the denominator should be similar. Right now you can see 2 and 2, both of the denominators are similar, so denominator will be written as it is, and numerator will be added or subtracted or whatever we want to do. So minus 1 plus 1, that was available on the numerator, minus 1 and plus 1, divided by 3 raised to the power 1 by 2. Now 3 minus 1 plus 1 is 0, so 3 raised to the power 0 divided by 2, divided by 3 raised to the power 1 over 2. And when 0 is divided by any number, you are always going to get 0. then denominator will remain as it is, 3 raised to the power 1 over 2. We studied the rule of exponent. When some number or some base will be raised to the power 0, the answer will be simply 1. That is the one of the rule we studied for exponent, and the 3 raised to the power 1 by 2 will remain as it is. So this is the simplified form for this question number 4. Now we have 36 raised to the power 1 by 2 times 6 raised to the power 1 by 2, and this whole thing is being divided by 8 raised to the power 1 by 2 times 27 raised to the power 1 by 2, and this whole thing under the and this whole thing raised to the power 3. So what we can do is we can distribute this power to all of the numerator and to the over the numerator and denominator, or what we can do is we can simplify whatever we have inside, and then we can apply this. Then after this we can apply this power. So we're going to go with the second one, where we're going to first solve whatever we have inside, and then we're going to apply the power, the whole power. So we have 36 raised to the power 1 over 2, and this is 6 raised to the power 1 over 2. Now both are having different bases, so we cannot, and they're being multiplied, so we cannot actually add them. So what we can do here, let's just simplify the exponent, each of the exponent. So what we're going to do is going to simplify each of the number. So this is 36 raised to the power 1 by 2 means square root of 36, and square root of any number means we're going to look for a number which is being multiplied with itself to give 36, and that number is 6, because 6 times 6 is 36. So instead of 36 we can write 6 times 6 raised to the power 1 over 2. Then here it's simply the root of square root of 6, and but we do know there is no such number which can be multiplied with itself to give us a 6. So this will remain as it is, 6 raised to the power 1 over 2. In the denominator we have the number 8 raised to the power 1 over 2 means the square root. So what we can do, we're going to look for a number with which it can be multiplied to give us 8, and we do know there is no such number, no such number exists. So what we can do here, we can take the LCM of 8 and think whether we can make the any pair or not. So 8 raised to the power 1 over 2, and we do know there doesn't exist such, there is no such number which is being multiplied with itself to give us 8. But what we can do here, we can simplify this 8 as 2 4 times 8. 2 times is 4, and 2 1 times is 2. It means this 8 can be written as 2 times 2 times 2. But we do want the square root. Square root means only the pairs of 2. So what we can do here, we can make a pair of with this one and leave this one. Similarly, same thing is we're going to do here, because the square root of 27 is not possible. So we're gonna write 27 as, because we know 27 can be written as 3 times is 9, and 9 3 times is 27. And if you can get this how I've written this, you can simply take the LCM of 27, and as you know 27 is not divisible by 2, it's an odd number, so it will be divisible by 3. 3 9 times is 27, 3 3 times is 9, and 3 1 times is 3. Okay, now here this 6 will be and this whole thing will be raised to the power 3. Now here this is a pair, so when you have some two similar numbers multiplied with itself, it will be raised to the power of 2 times 6 raised to the power 1 over 2. And in the denominator, what we're going to do, we're going to make this one as a power of 2, because this is a pair. So we're going to write it as 2 to the power 2 dot, or multiplied by 2 raised to the power 1 over 2. And why we did this? Because as you know, when you have two numbers which are being multiplied and they are being raised to a single power, that power will be splitted over both of them, and when this power will be splitted here and here, we can cancel out this 2. And we're going to do the similar thing here. The next number, it will be 3 raised to the power 2 dot or multiply 3. And why we make the pair of 2? Why we make the pairs of 2? Because here it's in the denominator, it's representing the square root. If it will be cube root, we'll try to make the pair. We'll try to make the triplets. Now this 2 and 2 will get cancelled, and we'll be left with 6 times 6 to the power 1 over 2 divided by, here we do know that the both numbers which are being multiplied raised to the similar power, so this power will be distributed over both of them. So 1 over 2 and 2 to the power 1 over 2. Nothing is going to happen for this 3. This power is going to be distributed here, 2 to the power 1 over 2, and it will be distributed over the other one as well, 1 over 2. Now whatever the simplification we can do, we'll try to do that simplification. This simple thing is will raise to the power 3. Here it will be 6 dot 6 raised to the power 1 over 2 divided by, here this 2 and 2 will get cancelled, will be left with 2. It will be 2 raised to the power 1 by 2, and it will get cancelled the square and the root. This will be 3 times 3 times 3 to the power 1 over 2. What we can do here, this 6 will remain as it is, and this 6 will remain as it is right now. In the denominator we have some of the numbers which we can multiply, and as you know, in the multiplication order doesn't matter that it's mandatory to multiply this with this one first and then with this one. No, you can multiply in any order, means you can multiply 2 with this 3 or 2 with this 3 as well. Okay, because if you do know 2 times 3 or 3 times 2, it's a similar thing, because you do know multiplication is commutative and associative as well. So order doesn't matter. We're going to multiply 2 with this 3 first. We're going to get 6, and we'll be just left with 2 raised to the power 1 over 2 and then 3 raised to the power 1 over 2. And if you can see here, we have 6 and 6 raised to the power 1 by 2 multiplied here, and similarly we have numbers in the denominators which are being multiplied. So what we can do, it means they are just acting as a single term, so we can do the cancellation. So this can get cancelled with this one, so we will be left with, and this whole raised to the power 3. So we can write it as 6 to the power 1 over 2. And in the denominator, if you look, you have two numbers, bases are different, but they are being raised to the similar power. So what we can do, we can write them together in a single group with the same power written outside, because we do know that if we have a power and we have a group, that power is going to and we have a group where two numbers are being multiplied, the power will be distributed inside. So we can do the reverse of that, if you have two numbers which are with the different bases but similar powers and they are being multiplied, so what you can do, you can just write their bases in the inside a group, and that group will be raised to that similar power, and it will become 6 raised to the power 1 over 2. And this 2 and 3, 2 times 3 will become 6. This 6 raised to the power 1, and this will also become 6 raised to the power 1 over 2, and this whole thing will be raised to the power 3. And if you look at here in the numerator and denominator, what we can figure out that both of them are similar, so the both of them will get cancelled, because whenever you have in a fraction numerator and denominator both are similar, they can get cancelled. Or what you can do, you can apply the rule of exponents if you want. So let us apply the rule of exponents. We do know bases are similar, powers are going and they are being divided, so powers are going to be subtracted. 1 by 2 minus 1 over 2, and this whole thing is raised to the power 3. And if we are not going to solve it just like a fraction, we do know there are two numbers with both of them are similar with the opposite sign, so they will get cancelled and we will be left with only 0. 6 raised to the power 0 is simply 1, because we do know any number raised to the power 0 will give us 1, and 1 raised to the power 3 means 1 will be multiplied with itself 3 times, and it will give us the simple answer 1 raised to the 7th root 1 over 7. What we can do here, we are going to do the similar technique we used in the last question. We are going to solve inside whatever we have inside, and when we'll be done with solving whatever we have inside, then we are going to discuss about this 7th root. So to solve inside, there is just a number 2187 and there is no other number for this, so we're gonna just write it right now as it is, 2187, 2187. But if you're going to look this one, this is a raised to the power 5 and this is a raised to the power 12, and so it means the bases are similar and they are being divisible. So I am just going to write this in a separate fraction, a raised to the power 5 over a raised to the power 12, and similarly here b raised to the power 17 over b raised to the power 3 as well. Why I'm writing them separately? Because we do know their bases are similar and they are being divisible, so the powers are going to be subtracted, and this whole thing raised to the power 1 over 7. And how I can write this is a single fraction in terms of 3 fractions which are being multiplied. So we already know a lot about fractions when they are being multiplied. So when 2 fractions will be multiplied, they are going to be written, for example, 1 by 2 times 4 over 6. So when they are going to be multiplied, they will be written in a single fraction with whatever we have in the numerator and whatever we have in the denominator being multiplied together. And if we can write like this, we can do the reverse of this as well, that if we have this 1 times 4 by 2 times 6, we can write them as a separate fraction. So we did a similar thing here. We have written 2187 separately, then these two with a fraction separately, and these two with a fraction separately. And we do know that this is a similar thing what we have here, because first if we want to, for example, join them together, so we're going to multiply the numerator together and denominator together, and we'll get the similar thing back. So now we're going to move forward. 2187, here bases are similar and powers are going to be subtracted, so 5 minus 12, why subtracted? Because they both are being divisible. Then we have b raised to the power 17 minus 3, and this whole raised to the power 1 over 7. Now 2187, and this is a to the power minus 7. We're going to subtract them because 5 is with the positive sign, plus minus minus. So 12 minus 5 is 7 with the sign of the larger value, which is 12, so we're going to write negative. Then we have b, which is 17 minus 3. So 17 minus 3 will become 14, and with the positive sign. Why? Because the sign of 14 is positive, and how do we know? Because there is no sign in front of it, so it's considered this is positive. So in this whole thing is raised to the 7th root. Now what we do know, that when we have 2 3 when we have numbers which are being multiplied and they are raised to a power, so what we're going to do, we're going to distribute that power on each of the term, each of the element. So this element, and this element, this will be distributed on all of them. So 2187 raised to the power 1 over 7, then a raised to the power a minus 7 raised to the power 1 over 7, and b 14 raised to the power 1 over 7. And we do know here that when you have one fraction inside the bracket and one outside the bracket, we can just cancel them out, or we can simplify them. And we do know this 7 is in the denominator and this is in the numerator, and they both are divisible by 7. So 7 1 times is 7, and 7 2 times is 14. And this 7 and this 7, they both are divisible, so 7 and 7 gets cancelled. So here it's 2187 raised to the power 1 over 7, a raised to the power minus 1, b raised to the power 2. I'm not writing any sign between them because it's already understood if there is no sign between them, it means that's multiplication. So here if you look at this one, this is 2187 with the 7th root. So what we're going to do, we're going to write this in terms of its what we're going to do here, we're going to factorize 2187. Why we're going to factorize? So that maybe we can get some number which is being multiplied with itself 7 times to give this number. So it's 2187, so it's not even, so we cannot try with the 2, so we'll try with the 3. So 3 7 times is 21, and then 3 2 times is 6. Then 2 will be taken as a carry, and 3 9 times is 27. Then 3 2 times is 6, and the remainder will be 1, which will be taken as a carry over the next number. So 3 4 times 12, and 3 3 times is 9. After this again odd one, so 3 8 times 24, and 3 1 times is 3. Again 3 2 times is 6. If 3 2 times is 6, what will be the remainder? 2. So 3 7 times is 21. Then 3 9 times is 27. 3 3 times is 9. And 3 1 times is 3. So if we're gonna look here, all of the numbers we got are 3. All of the factors we got are 3. So 1 2 3 4 5 6 7. So what we got, that we can write this 2187 as 3 raised to the power 7, because 2187 is the number, because we want to find the root, 7th root of this 2187. Means we are looking for a number which is being multiplied with itself to get this number, to give this number. So that is simply 3. We got this by this so we get this by using this LCM by division method, and here it will be -1 and b raised to the power 2. So we do know this 7 inside and 1 by 7 outside will be multiplied, and when you have numerator and denominator multiplied similar, they both get cancelled. So it will be 3 a raised to the power -1 b to the power 2. And whenever you're going to have in the question, it's mentioned that now this is negative. So in the question it was mentioned our exponent should be positive. So whenever you're going to have a negative exponent, what you are going to do, just move it from the numerator to denominator, or if it's in the denominator, move it to the numerator. So right now in the numerator, and to make it positive, we'll just flip this and move it in the denominator. So that will be this simplified form. Okay, so to do this question number 7, we have question number 7. So in this one, if we're going to look for this first fourth root, we cannot simplify this. Why? The powers are 3, and 3 are not present in the table of 4, or they are not a multiple of 4. So 3 and 4, they both cannot be simplified. So what we can do, we can first let us try to convert this in the exponential form. Maybe it will become beneficial for us. So it will be written simply 1/4. Simply we're going to do the similar thing for this next one, because there is no other simplification possible. So we are just doing the conversion. Fourth root means simply 1/4. Here as well. Now after this, what we can do to simplify it further, we'll just split this power over the group, which here it means this 1/4 will be distributed over the numerator and the denominator. And when you have a power inside and outside, it's simply they are going to be multiplied. If I'm going to write it as, it will be a 3 raised to the power 1/4, and then b 3 will be raised to the power 1/4. It's going to do the similar thing over the next root, b cube raised to the power 1/4, because the whole group was raised to the power 1/4, the fractional exponent. And the rule of indices, or the power or exponent, says that we can distribute it in the numerator and the denominator. So here we have a power inside, and that outside the bracket we have another power, and we studied the rule that we are going to have a power inside and outside the bracket. We're going to multiply them. 3 times 1 by 4 is 3 by 4. Going to do the similar thing in the denominator. B raised to the power 3 divided by 4, or 3 by 4, times a raised to the, sorry, here similar thing, b raised to the power 3 over 4, c raised to the power 3 over 4, times c raised to the power 3 over 4, and a raised to the power 3 over 4. And now we have the fractions which are being multiplied, and when we have fractions which are being multiplied, we can do the cancellation vertically, like above and below, and diagonally as well. So if you are going to look, this c3 by 4 and this c3 by 4 both are similar, so they get cancelled. Or what we can do, the other thing we can do is, why don't we rearrange them? We can do the cancellation, like we can cancel this one with this one with this, and this one with this, and we are going to just get one. One way to do this is like this way, but right now I'll just prefer to do with the rule of indices, that as you know, that's a fraction, so we can actually rearrange the numerators and denominators, and that's not going to make any difference because multiplication is commutative. So what we're going to do, we'll first try to, as you know, fractions are being multiplied, so I'll just write them, all of them, in a single fraction, to just show you that when we have fractions and they are being multiplied, we will just multiply the numerator with the numerator and denominator with the denominator. This one and this b raised to the power 3 over 4 times c raised to the power 3 over 4 times a raised to the power times a raised to the power 3 over 4. Now here this is a, and we do know that we can make the fractions by any of the numerator, by taking any number from the numerator and any from the denominator. So we'll just take with a similar base here, a raised to the power 3 by 4, a raised to the power 3 by 4. Similarly, now we're gonna make the other fraction with these b's. So 3 over 4 and b raised to the power 3 over 4, and then c raised to the power 3 over 4 and c raised to the power 3 over 4. And bases are similar. We can see here bases are similar, powers are going to be subtracted because they are being divided. So 3 by 4 minus 3 by 4, then we have b raised to the power 3 by 4 minus 3 by 4, then c raised to the power 3 by 4 minus 3 by 4. Similar numbers with opposite signs going to be gets cancelled. A with the left power 0, simply b will be left with the power 0, and c will be left with the power 0. So anything raised to the power 0, it's simply 1. So 1 times 1 times 1 is simply 1. One way is to do like this by using the each of the rule, or the other way is to just do the cancellation, because in the multiplication we can do the cancellation above and below and the diagonally, so we'll get the 1 here. Whatever you like, you can go with that procedure.
Now we have the last question of this exercise 1.2, which is use suitable laws of exponent to show that this thing is equals to this thing, means it has two sides. So if you're going to look at this question, this has two sides. The left side, because you can see the equality here, and the equality on the left of the equality, that's called left hand side, and on the right of that, that's called right hand side. Now what we want to show, we want to prove them that they both are equal. So there are two ways to show this. One way is to go with the left hand side. We'll go with left hand side and solve it further and get the right hand side. In this way, that left hand side will be equals to right hand side. Or the other way is to go with the right hand side, and then ultimately by the simplifications or whatever the process you can do, you can prove it equals to you can make it look like similar to left hand side. In this way they both will also be equal. Or the other third way is the third approach is that we're gonna use both of the sides together, left hand side and the right hand side, both will be solved together at the end, and at the point where both of the sides start looking similar, you're gonna write that the both sides are equal. These are the three approaches here. Right now we're going to use the very first approach, that we're going to use the left hand side, and we're going to try to prove with this left hand side, and we'll do the simplifications to get the right hand side. So in this left hand side, we can see here that we have the similar bases which are raised to different powers, but they are being divided. So when you have two numbers which are being divisible and they are having the similar base, so you're going to subtract the power. So this will be p minus q, and outside this bracket that will be p plus q. Then after this, if we're gonna look, there is a multiplication, and after this we have this third side. We're gonna write it left hand side equals to, when we are doing the left hand side solution. Okay, so and then we have this y, this will be written as y, similar base, powers are going to be subtracted, so this will be q minus r, and this whole thing is outside this you have q plus r as well. This is q plus r. And then after this we have this z, where same base is divisible, so we're gonna just subtract the powers. So z raised to the power r minus p, and this whole thing raised to the power r plus p. And after this we have xq square y times y r square and times z p square. Now here what we can see inside the bracket there is a power, and outside the bracket there is a power, so both are going to be multiplied. So right now they are not just numbers which we can multiply and write it as a single will get a single number. So we're just going to write the power as it is with the multiplication to show they are just going to be multiplied, p minus q into p plus q. And similar thing is going to happen in the next one. Here as well you can see q minus r inside over as a power and q plus r outside, so both are going to be multiplied. So y raised to the power q minus r into q plus r, and as we haven't mentioned any sign between these two groups, so it means they are being multiplied. Same thing is going to happen here, z raised to the power r minus p into r plus p, and with this one the remaining things will remain as it is because there is nothing to do here. This will be q square times y raised to the power r square times z raised to the power p square. Now here the both things are going to be multiplied. So the easy way to multiply these two is this. If you do remember the rule that when you have two groups which are being multiplied, and the first group if you have two terms, in the first you have the terms, and the second group you have the similar terms, but the difference is that in the first one they are with the negative sign, and in the other one they are with the positive sign. So whenever this thing happens, that will be equals to the square of the first term minus square of the second term. So whenever you have the two copies of two terms, with the one with the negative sign, one with the plus sign, then you're going to have the square of those terms with the subtraction inside them. So here we can see p q, both of the terms similar, and just two copies with one minus sign and the other one plus sign, so it will be simply p square minus q square. Then times y, here it's raised to the power q minus r, q plus r, similarly both are similar, q r, just the sign difference. So it will be q square minus r square. Then z raised to the power, the same thing is going to happen here, r square minus p square times x q square y r square and then z p square. After this, here what we can do further, because in the multiplication is commutative and associative as well, so it means order doesn't matter. Whatever we want to multiply, we can multiply first. It means the thing I'm saying is that if it's 2 times 3 times 6 times 8, it's up to you. You want to multiply 2 with 3 first or 6 first or 8, so you can rearrange it as 2 times 6 times 8 times 3. Okay, so we're going to do the similar thing here. We're going to we're going to write those numbers which are having the similar base together. So p square minus q square, and this x is having the similar base, so it will be rearranged and written here because multiplication is commutative. So q square will come here, and then we have y, so it's y raised to the power q square minus r square, and then this y is simply raised to the power r square. So y raised to the power r square. Then we have z, where z is raised to the power r square minus p square, r square minus p square times z raised to the power p square. Now we do know bases are similar, they are being multiplied, so powers are going to be added. So here x will be raised to the power p square minus q square, and the other power on the other number with a similar base was q square, and then they are going to be added. Similarly here y raised to the power q square minus r square, and here that will be simply, this is raised to the power r square, so both of the powers are going to be added, so I'm writing the addition between them. Then we have z, which is raised to the power r square minus p square plus p square. And what I forgot in the last step to write these, okay, no, I didn't forgot anything. Then we have this q and q both are similar with opposite signs, gets cancelled, so this will be simply left with x raised to the power p square, and then we have these r square, both are similar with the opposite signs, and whenever you have two numbers which are so it will be y raised to the power q square, and then here p square and p square both are similar, so it will be z raised to the power r square. So if you're gonna look here, this one and this one, the right hand side, they both are equal, so I'm gonna write it equals to right hand side. So what we did, we started from left hand side and we did this simplification and we got the right hand side. So this proves that left hand side is equals to right hand side, or the other way to write this, you're gonna write the whole, you can write this whole question and say, so prove this whole question is correct. So thank you for your time. See you next time.